let's go ahead and get to the actual Excel. This was sent to me by one of your colleagues, your classmates, and this is just one example of doing it. You don't have to do colors like this. You can if you'd like. You don't have to do columns. All I want is this right here. All I want is the label, graduated cylinder, just like you see on your worksheet. Again, you have your mass of your beaker plus 5 mils, mass plus 10, mass plus 15, and then here you have your masses for each corresponding molarity. So you're going to do that for the graduated cylinder, you're going to do that for the pipette, you're going to do that for the burette. Remember that the burette has two columns because they wanted you to do exact volume and exact mass. So your volume should be in liters. We measured in milliliters, so make sure you do that conversion. You can see here the milliliters in the equation sheet divided by 1000 will give you the milliliters. And you can simply do that on Excel. You can do it yourself and type in the numbers, whatever works for you. Yeah, I don't know what's going on here. Give me a second. There you go. Okay. Yeah, don't mess with the formulas. Alrighty. So density calculations are very straightforward. It's mass divided by volume. All right. This is something we've learned as far back as even eighth grade, I would imagine. So for the graduated cylinder, you're going to get your mass of each one, density measurement number one, number two, number three, number four. Remember, you did 5, 10, 15, 20 mils. So that's four measurements. All right. And you're just going to take the mass that you got. So for example, for the graduated cylinder, our mass of the 5 milliliters is 34.559, right? But also remember, this is the mass of the beaker plus the solution. You should have weighed the empty beaker by itself, so you can subtract the mass of the beaker plus solution from the mass of the beaker by itself. It's difference by weighing. The difference gives you the mass of the solution. So here you can see that this person already took the formula C3, which is going to be right here, the mass from the graduated cylinder column. They subtract the mass of the empty beaker. You can see that's what this number is right there. And you divide it by the volume. And then you fill it in. It automatically fills in. And that is going to be in grams per liter. And all of these values should be very close. You should not be getting 1,000, 2,000, 3,000, 4,000. Density is an intrinsic property of a solution, which means that any solution of NaCl at a certain concentration should have the same density no matter what. So all these numbers should be very close to each other. There should not be any significant variation in these numbers. So again, you just take your formula, full beaker minus empty beaker divided by volume, and then you fill it in. For your standard deviation, use this number right here, STDEV, and you get your standard deviation of your density measurements. You see here that it starts from C23 all the way to C26, which is right here. So that's what your standard deviation is going to be. Excel will take care of the rest. All right. In case you are required to show your standard deviation calculations, we are using sample standard deviation equation, which I believe can be found. Well, actually, I don't have it available, so never mind. You can look it up. Look up the equation for standard deviation for a sample, and that is the formula we will be using if you have to show a sample. But otherwise, make your life easy. Just let Excel do the work and fill in the numbers. So I don't really have much to say in terms of the spreadsheet. It's pretty straightforward. All of this comes from the data you got. So if there's any mistakes here, it's all human mistake, meaning you didn't input the numbers correctly, you didn't do your labeling correctly. Make sure that you tell me the units of these numbers. Like right here, you can see that it says grams, which is fine. You could also put it on the top. It doesn't really matter. I need to know that these numbers correspond to grams. I need to know that these numbers correspond to liters and a volume. And I need to know that density corresponds to grams per liter. So actually, that would be something good that I could include here in this column. I could just rename it uh, grams per liter. And that will give me right there the units of everything that I need. You see that? Yeah, I don't know why it's doing two or three. So again, you don't have to be all fancy and do super columns like this, but as long as you're getting the gist of what I'm saying, which is this should be grams per liter, grams per liter, grams per liter, okay? Excel is finicky, so just do it manually, do whatever you need to do. You will be printing out the spreadsheet and turning it in along with your graph. So speaking of the graph, let's get to it. Again, I think this is pretty straightforward. I don't think I have much to say. We are only going to be plotting the average density. Okay, so I'm going to highlight that to emphasize that we are using only the numbers of average density. And that one there, this one here. Let me do that. And then this one here. And again, make sure you emphasize which one it corresponds to. You can see here that's 1 molar, 6.6 molar, zero point 0.4 molar, zero point 0.2 molar. I take the values of my average density and I'm going to put them in a new table. This is where my data is ultimately going to come from. All right, all of the spreadsheet was simply so we can get to this point. We have our graduated cylinder average density for the corresponding molarity for the graduated cylinder, for the pipette, for the burette. So just like last time, we're going to be inserting a graph and we're going to be selecting the data. So I'm going to go to insert. Make sure you click on a random white empty space. Scatter plot, you should get something blank like this. If you don't, that's okay. We're going to end up doing the same thing anyway. So you're going to click on there. You should be in the tab that says chart design, select data. So here we go. We're going to start selecting our data. It's blocking the way, so let's make sure that we don't do that. So here we go again. Select data. I'm going to make a new series. This series is going to be called graduated cylinder or grad sil if you want. Your X values, and remember, what goes on the X axis? Concentration in molarity. So this is my X axis right there. Y values, remember, bracket 1 bracket. I don't know why that's there. Just forget about it. Here we go. And then OK. And then that should populate everything right there. And then I'm going to click OK. Now, for some strange reason, I am only getting one value here appearing. So I'm going to go ahead and pause right now and figure out what's going on. Okay, so I wasn't sure exactly what happened, but I guess I was just clicking the wrong thing. So there it is. There is the graph right there. You should see something very close to a line. And again, there's going to be natural variations. So if you don't see exactly a line, don't worry about it. That's the whole point of this experiment. We're going to try to see what matches what. So we do have our graduated cylinder data. So once again, we're going to click on the graph. We're going to click select data. You see we have the series right there. We're going to make a new series. We're going to call it pipette. X values, again, your X values is your molarity. Y values, remove the bracket 1 bracket, insert that, and you see it automatically populates right there. And then you click OK. And then we're going to do it one more time. This is exactly the same thing we did last week. So let's see. Series name, burette. Something happened to the graph again. I'm going to have to figure it out. Again, Excel is pretty finicky, guys, so you're just going to have to bear with it and try to go back and try to make sure the data fits. Okay, there we go. You see that? And then it automatically fills. Now we have our 3 data sets. I'm going to go ahead and click OK. There we have our chart. I'm going to move it down here to make it easier to see and to read for everybody. So here we go. Here's our chart. Let me explode it up a bit. So there's that. This screen is a bit too dark. Again, you can go in, click on the data point and select the color to make sure that it matches what you want. I'm gonna make it really bright. There you go, really bright green, look at that. And then this blue, I don't really like this blue, so I'm gonna go ahead and change that to fill again. I'm gonna make it like a purple. Purple stands out a lot. There you go. So now I could actually see my data points individually. So just like last time, you're gonna go to chart elements. You're going to put your axis titles. You're gonna put your chart title. You don't worry about your data labels. Definitely include a legend, and we are gonna be including trend lines. So we're gonna be including trend lines for all 3 of these. This is not one combined trend line. This time we are doing individual trend lines for each data series. So I'm gonna do it for graduated cylinder. I'm gonna do it for, let me see, trend line. Oh, okay. I guess I have to do it from the data. Make sure you right-click the data then by itself. Click Add Trend Line. There's my trend line. Display equation on chart. So there's my equation. And then I'm going to also make sure that I include my R squared value. Format trend line, R squared value. Yeah, make sure you do that all at once. And then just to make things easier for you, I will right away go and change this font or the color to something different. So I'm gonna make this colored red. Well, actually, no, this is for the burette. The burette is green. I'm gonna go ahead and color this green so that I know what matches what. So there it is. This is the burette right there. And so once again, I am going to include a trend line for this time the orange data set, which is corresponding to the pipette. And trend line, you can see the trend line is orange. And once again, set equation on chart, display R squared value. Make sure you click that over to the other area. You might have to insert a text box or just write it when you print it out that each of these equations corresponds to each of these things, but you can also just do it on Excel. So again, the red is orange. I'm going to make this orange. There you go. And finally, we're going to do the same thing for the purple one, which corresponds to the graduated cylinder. So add trend line. There's my trend line right there. Everything should be a linear trend line, okay? Make sure everything is linear. All right. So here we go again. Display equation on chart, and there it is. And so since this one is purple, I'm going to go ahead and make it a very bright purple. So there you go. Now I have my equations, my R squared values for each of these. And again, make sure you include your units. Remember that the units of the slope are going to be in grams per mole. So grams per mole. That is your molar mass, okay? That is your molar mass. And then the y-intercept is going to be grams per liter. Parentheses, grams per liter. And I'm not going to go ahead and do that to all of these. You can go ahead and do that, but make sure that you have your units in there as well. So now you have your 3 data sets. Now you have your 3 trend lines. Now you have your 3 R squared values. And you can see that one data set is a little weird, right? This one is like 22.424. That's way off from the accepted molar mass of NaCl, which I believe is 58.44. Check me on that, but I know it is 58 something. You can see this one is a little closer, 59.31. And finally, this purple one is 58.188. So we know some stuff. For example, we know volumetric flasks are more accurate than graduated cylinders, but maybe human error, maybe we eyeballed it incorrectly. Whatever the reason is, this is why we take data. The data ultimately tells us or forces us to draw a conclusion. And then when somebody else does it, they can compare that data to our data and they can say, oh, well, actually, I got different results. And that's science, right? So just because we get one result does not necessarily mean we can draw an absolute conclusion about the accuracy of these glasswares or, oh, the TA was not telling the truth. The graduated cylinder is actually the most accurate one. Based on this data, it appears that the graduated cylinder actually is the most accurate. But again, that's not necessarily true. There could have been many factors into this. And actually, I would encourage who's ever graphed this to check their data for their burette. Perhaps there is something going on there that is causing that. Personally, I think it's this slight outlier right here. Maybe this should have been a little higher. Maybe the burette was not measured properly. Who knows? Whatever the reason is, the data is what it is. For the title, make sure you're including exactly what it shows you here. It's telling you calculated density versus molarity. So we're going to go back over here and say, for my chart title, calculated density in grams per liter versus molarity of NaCl solution using 3 different glasswares. That's a pretty decent title. The title should be descriptive. For your y-axis, remember what was it? It was your calculated density in grams per liter. Calculated density in grams per liter. And finally, for the x-axis, it was the concentration of NaCl in molarity. Make sure we do that. You could type out concentration or you could use the brackets. Remember, brackets means molarity. So you could do brackets, NaCl, bracket, and then make sure that you include it in molarity. So if you have this chart would be considered complete. I personally like to include my legend at the bottom. So in order to change that, you can go back to the chart elements. And then when you go ahead and click your legend, there's a little side menu and you could put that at the bottom. And that actually gives you a lot more space. You could see that our x-axis data range is a little bit wacky. So again, you click the x-axis, right click, format axis. And over here on the right, you can see that it says minimum 0, maximum 1.2. That's ridiculous. We only went up to 1. And then the minimum, we didn't go to 0. The minimum was 0.2. So let's go ahead and keep our chart neat looking like this. Okay. And there you go. So now we have our trend lines. Now we have our data series. Now we have our graphs. This is a little messy. It's kind of all over the place. Make sure you organize it, make it look aesthetic. I know you guys know what that looks like. You can use the comparison from the lab manual to compare it to. So this is what you're going to be turning in. Let me get rid of the side menu. You're going to be turning in your graph and you're going to be turning in your spreadsheet. And that's really it. There's not much more to it. This is not much different from what we did last week. Let me see if I can change the font. Nope, let me see if I can change the font. No, that doesn't work. Okay, so don't change the font of your graph. Just put it on a separate page and put your spreadsheet on a separate page. But that is pretty much it. There's not really much to it, guys. The Excel functions are exactly what we learned last time. Density is a straightforward formula. It's one cell divided by another cell. Um, the graph is exactly the same instructions as last week. So if you have any particularly specific problems, make sure you write them down. Come to office hours on Tuesday or let me know on Tuesday morning. Okay? I think that's all I have to say regarding this data series and data sets. So just let me know if you have any questions. And once again, thank you for your time and thank you for your attention. I highly appreciate it. And have a good afternoon. Have a good weekend.